A capacitor and an inductor are two energy storage components. After the power supply finishes charging the capacitor and the switch is flipped to the inductor, you can see that the voltage across the inductor becomes a sine wave. The sine wave's frequency is 1/2 pi multiplied by the square root of L times C. At this point, we say that the inductor and capacitor are oscillating. Because both components have losses, the oscillation gradually decays until it disappears, completely similar to a damped oscillation. Let's now look at how an LC circuit produces oscillation. After the capacitor is fully charged, the upper plate holds positive charge and the lower plate holds negative charge. When the capacitor is connected to the inductor, it begins to discharge through the inductor, and the current flows into the inductor from the top and exits from the bottom. The electrical energy stored in the capacitor gradually converts into magnetic energy in the inductor. The voltage across both the capacitor and inductor gradually decreases while the current through the inductor gradually increases. When all of the capacitor's stored energy has been converted into magnetic energy, the voltage across the LC circuit drops to 0, and the current through the inductor reaches its maximum in the forward direction. After the capacitor finishes releasing its energy, the magnetic energy stored in the inductor begins converting back into electrical energy in the capacitor, and the current direction remains the same as before. The inductor then charges the capacitor in the opposite polarity, causing the voltage across the LC circuit to rise in the reverse direction, while the current gradually decreases. When all the magnetic energy has been converted back into the capacitor's electrical energy, the voltage across the LC circuit reaches its maximum negative value and the current through the inductor drops to 0. Then the capacitor discharges again through the inductor in the reverse direction, gradually converting its stored electrical energy into magnetic energy. The current in the inductor now flows from the bottom to the top, opposite to the previous direction. The voltage across the LC circuit decreases from its maximum negative value while the current in the opposite direction gradually increases. When all of the capacitor's stored energy has again been converted into magnetic energy, the voltage across both components becomes 0 and the reverse current reaches its maximum. After the capacitor releases its energy, the magnetic energy in the inductor transforms back into capacitor energy once again, with the current direction remaining the same as in the previous step. The inductor charges the capacitor in the forward polarity, raising the voltage across the LC circuit while the reverse current gradually decreases. When the magnetic energy is fully converted back into electrical energy in the capacitor, the voltage reaches its maximum positive value and the current falls to 0 again. The inductor and capacitor then repeat these 4 steps again and again, producing the oscillating sine wave signal we observe. This is the process by which an LC circuit generates oscillation. Ultimately, it is simply a process of energy exchange between the inductor and capacitor. That's all for today's explanation. Thank you for watching.